a lot of interest across the IARPC team. So I'm the co-chair of the IARPC observing team. And this is a conversation that we've raised a few times in the context of observational systems and improved sort of integration and exploitation of observational systems. But additionally, it is, and I'm just going to make one small adjustment. Additionally, it's a conversation that the terrestrial team has been really interested in. And in fact, a previous wildfires team got merged with the terrestrial team a couple years ago. And Randy Jant, who's on the line, used to be the co-chair of that team and really carried this conversation in the IARPC for many years. One of the things that we had two different topics on our call the last time. One was led by Bill Sjoberg of the JPSS Arctic Initiative within NOAA, and he did a readout of a day-long symposium they had on satellite products for wildfire smoke detection. And if there was sort of one slide that encapsulated everything they had said, I would share it here. But he really gave a very rich presentation. I'd encourage people to go back to those meeting notes and sort of look through all of the different capabilities that satellite constellation has for smoke detection and how it's being integrated with other observing and forecast activities within NOAA, but also at UAF. And then the second thing that we talked about was to generate some kind of a system-wide assessment of what kinds of observational capabilities are available for wildfire smoke detection, principally in Alaska. And this builds off some work that we've been doing from within the U.S. Arctic Observing Network to try to create these improved end-to-end mappings of observational systems through the intermediary data products to the types of forecast and platform systems that they support. This is a task team effort of USAON. There is a wildfire smoke detection task team that had been initially convened by Ed Washburn. Ed's now retired, but we're still keeping the momentum moving forward from what Ed had started. So a lot of what I'm going to show are readouts from material that Ed had created. And this presentation is also posted already on the IARPC website from that May meeting of our two teams. And so I'll go into full screen mode so it's a little easier to do. So just generally the purpose of these mapping exercises, we want to clarify the user base for the observing system to really understand where we can be most targeted and most effective in the observing system design. We know too that there's often different kinds of barriers to using observational data, whether it's a latency issue, whether there's poorly understood uncertainty estimates, whether the data products are not well assembled. These kinds of things are one of the things that we can identify in doing an assessment like this. Of course, the overarching purpose is to improve the readiness, or I shouldn't say the overarching purpose. Another purpose is to improve readiness for the future observing system so that we make sure that we have adequate observational capabilities. And then this concept of essential variables is often used in these systematic framework approaches as well, because they provide a means for structuring these interorganizational efforts. And so essential variables don't always mean the same thing as variables that we think about in the typical observing system sense. They're usually more of an organizational unit, as broad as something like sea ice, for example. But wildfire smoke would probably be the appropriate breadth. So we had developed this example for sea ice forecasting from another USAON task team, and this is just focused on one particular sea ice forecasting model. It's listed here as SCARF. Its new name is CAFS, the Coupled Arctic Forecasting System. And starting from the middle, what we did is we worked our way backwards from this application space through the different parameters or phenomena that are used to initialize this model, back through where they're finding the products and service data products that are used to initialize the model, and then back to the observing systems that underpin them. And then moving in the forward direction, we connect the application with the different end users who are using it, and then try to understand how this is supporting different societal benefit areas using a pre-existing Arctic societal benefit area framework that was developed last year through the international community. And so while this is a very high-level example, the power of doing these mapping exercises arises when you layer up multiple types of applications, multiple types of observing systems, multiple types of end-user services, and can begin to see the fuller landscape and where the opportunities are to take advantage, leverage, streamline, improve, etc. And so what we did on our last call was we put up an example kind of straw man for what the space for mapping for smoke detection and forecasting might look like. And you can see, you know, there's a lot of different places where we could start this exercise, moving it right to left from observing systems themselves, like the JPSS constellation and their fire and smoke initiative. Or we could start with things like the UAF smoke model and move it backwards as we did with the CA's forecasting system. So this is a bit what we talked about in our last call. There was a lot of enthusiasm to sort of re-spark this task team, draw in people who are subject matter experts under, be it the observing systems, be it the product service space, the application space, or the end user space, to try to develop this type of systematic mapping. And so hopefully some of the conversations we have on this call today will fill in more gaps and give us more ideas. But this is, you know, I'll pause here, or I'll end here just to say we'll keep people posted on this activity. If you're interested in getting involved, maybe include your name in the chat and I will follow up with you. So that's all I've got from the recap. I'm happy to field questions.
Thanks, Sandy. Any questions? Okay, hearing none, but we'll have a chance later if there are questions that come up. So it's possible I had too much caffeine today and I forgot to give Heis the opportunity to introduce himself and represent the atmosphere side of this call. So sorry about that, Heis. If there's anything you'd like to say before we continue on with our agenda, feel free to jump in.
No problem. I don't have much to add. I think you did a nice job of summarizing the call. Generally, the atmosphere team has been very interested in thinking about forecasting products for smoke and how we can better understand smoke transport, and then connecting it back to teams such as yours and understanding the health aspects of that and where the users lie. And so I think you did a nice job of introducing it, and I don't have much more to add other than Ashley and Barry and myself are excited to be part of this call.
Same here.
Great, thanks. Mike Brubaker, are you on the line?
I'll go ahead and send him an email. Okay.
Well, while we wait on Mike, perhaps we can jump to Martin. If you're ready, Martin, to present on the UAF Smoke Project,
sure.
That would be great. Okay, thank you.
Let me just share my screen. Can you see something?
Not yet.
Currently, we just see you.
Uh-oh. How does that look like?
Yeah, that's better.
And I have two screens, so I hope I share the right one here.
We're seeing the other one at the moment.
Yeah, we see the two slides.
Uh-oh, okay.
There's a swap displays button at the top. Maybe click on that and see.
I just switched one off. How about this?
No, we still see the second display. But if you look at the top of your screen, there should be a little swap displays icon. You see that? I think maybe we lost Martin altogether.
Let's see. I do not see him on the list of participants anymore.
No, and it looks like his hip is frozen.
Well, while we wait on hopefully Martin to get back online, are there anything that anyone would like to bring up? Any questions about anything?
I guess.
Or maybe just time to sip your coffee.
It might be interesting to see that last slide that Sandy had up. Think about that a little bit more. It was pretty quick there. So Sandy, if you're still on, yeah, that one. So I think, from our side, personally, I'm not as entrenched in the smoke observation or forecasting side of things, but it would be interesting to hear from others on the call.
I'm sorry. Can you hear me now?
Oh, looks like Martin's back.
For those that are not speaking, would you mind muting your phones, please? Thank you.
Can you see me? Can you hear me?
Yep, we can see and hear you. We still see the next slide, but given the technical difficulty, I think it will be okay.
How can I switch the screens?
So Martin, at the top of the presenter display that has both, there's a swap displays icon. See that?
Let me. Swap displays. Okay. Now it works, huh? Thanks.
Looks good.
Are you there? Now it should work, right?
Yes, we've got you. We hear you and we see it.
Okay. Sorry for the difficulties. So thanks for inviting me to present on our UAF Smoke Project. That's a ongoing project since actually 14 years now. And I want to start out. I know many of you are very familiar with Alaska fires, but a little bit of background. What's our motivation? That's a color-coded fire burned area in decadal color codes since 1942, 2015. You can see, of course, due to the continental climate, that most of the fires occur in interior Alaska. There are some large fires also in the south of the Alaska Range, and some tundra fires, which are, of course, of high concern for the Arctic. Fire occurrence, there are especially in recent years, we had some pretty large fires. I have to find my mouse. Yeah, 2004 was record fire year, and with over 6.6 million acres burned, 27,000 square kilometers, and then we had the year 2015 here on the right edge, which was even of more concern. Over 5 million acres burned, but the fire season was very short, and I know Randy talked about it before too. That's of high concern due to future possible fire scenarios due to our changed climate, longer fire seasons, early onsets of fire seasons. You can see on the right over 5 million acres in 2015. The fire season was more or less confined to 2 months, May, June. We had extremely warm temperatures, in May was in Alaska about 7 degrees Fahrenheit warmer than the normal, and we had strong, that's accumulated temperatures, strong warming in May, a lot of unstable air and very dry conditions until about mid to end June, last 3rd of June. Some rain started, which reduced the fire activity. We had a lot of lightning strikes, up to between days up to 60 new fires per day due to lightning strikes. So most fires were lightning caused, and over 70,000 lightning strikes you can see here in May. So these are possible future scenarios. The fire season, as I said, ended more or less early in 2015, but if that weather situation would have been ongoing, it would have been a devastating year for Alaska. And it's totally possible to have such stable weather situations in the future, and so we have to be prepared. It was mainly after 2004 when we did a lot of work with the weather research forecast model, and especially with the coupled chemistry WRF-Chem model. And so we were tasked to build applications for fire emissions. We teamed up with our colleagues from the NOAA Earth System Research Lab with George Grell, his team, and with Saulo Freitas, those days from Brazil, Center of Weather and Climate Studies. Saulo is now with NASA Goddard. Alaska is always attractive for many people, so it's nice to invite collaborators and find them. And we have a perfect test bed for fires, for fire research. We also have a perfect test bed for volcanoes shown here. I know that's not the topic, but I put in this slide because we build applications for WRF-Chem for biomass burn emissions as well as for volcanic eruptions. And why do we use WRF-Chem? Of course, there are other great models out there. An advantage of WRF-Chem is that it's a coupled model, so we can simulate the emissions coupled to the atmosphere on identical spatial grid cells on identical time steps, and therefore study feedback to the weather. Saulo Freitas and his wife Carla Longo, they developed a emission data generator for those days the 3PM, the Brazilian biomass burn emission model for Brazil, and we used this emission data generator package to apply it and integrate it in the WRF-Chem model. PrepChem sources, that's the name of this package, is now available within the WRF-Chem public domain. So anybody can download it and easily calculate emissions or map emissions from wildfires, also anthropogenic, other sources, biogenic sources, to the WRF domain, which is of interest for the respective studies. Emissions from wildfires are calculated mostly in a bottom-up approach. So emissions are directly related to the area which is burning, to the fuel loading, emission efficiency, and emission factors. The advantage, as mentioned, we can calculate feedback processes within WRF-Chem. We can study aerosol direct, indirect, semi-direct effects. That's an example of a study from using fire data from 2004. Looking at the direct effects of fire or smoke particles on radiation. What we found is partly a very significant warming of the upper boundary layer. Here on the left is the difference of the temperature between a WRF run with fire emissions and the WRF run without emissions. So you can see partly warming of the upper boundary layer, a more stable boundary layer, And we also found differences in the water vapor mixing ratios. And the studies allow very well to verify if WAF does a good parameterization of those effects. We also showed changes of precipitation due to the smoke particles, increased connectivity in the afternoons. Those are increased precipitation with the WAF can run with fires on the right and compared to the left without. So you see partly regionally significant higher convective activity here due to the fires. With extreme aerosol cases like fires, wildfires, the weather forecast model actually improves by considering fire emissions. So there is some incentive using WAF-Chem or a coupled model. We do WAF-Chem runs daily during the fire season. We are now at the beginning of this year's fire season. We already have just had this weekend quite a fire 50 miles southeast of Fairbanks, and in the area, Alaska, there are several fires ongoing right now. So we are in the process within the next days to run our daily smoke forecasts using the WAF-Chem model on smoke.alaska.edu. You can find some forecast products. Of course, we always say we develop better graphics next year, and then there's another year. So hopefully we get to better products soon. But we produce 72-hour forecasts and get quite some feedback, especially during extreme fire years. And it helps the public. It also helps the fire managers and smoke managers. For initialization, we use a hybrid fire product. A main challenge with forecasting fires, of emissions from fires, is to get the areas right, the fire characteristics, how much is burning, how intense. We are in a very lucky situation to have in Alaska the Alaskan Interagency Coordination Center, which produces or does tremendous work to provide fire information data updated several times daily. We also have the Geographic Information Network of Alaska, GINA, here in-house at the University of Alaska. And GINA is a downlink station, provides downlinks and direct readouts of and produces MODIS and VIIRS fire thermal anomalies. And so we use a hybrid of different satellite products, airborne observations from the ground to initialize our smoke forecasts. That's a main difference of UAF Smoke to other products, but we are very excited. Our colleagues from NOAA Earth System Research Lab, and we saw some, it mentioned before, they are Ravan Akhmadov there and George Grell, Trevor Alcott, they produce now a smoke forecast using the high resolution rapid refresh model. Those are experimental forecasts, but they are going into non-experimental forecasts. Hopefully, Ravan mentioned something 2020 timeframe. That's an example for the lower 48. Ravan did not start the runs for Alaska yet. He's actually working to integrate fire emissions in the larger domain of the rapid refresh model. You see it's a pretty large domain, including all over Canada, Alaska, and of course the contiguous US. Those smoke forecasts have been proven very useful, especially during last year's big fires, California fires all over the states, but we are working with Ravan and the group intensively, and they use fire radiative power from VIIRS to initialize the runs, which is a great product, but we miss some fire points. Chris Weigel, she was a graduate student with me. She studied VIIRS fire products intensively, and she found that VIIRS offers a higher detection likelihood to MODIS, but there are some events and a significant amount of events which we miss. Of course, a lot of fires in Alaska are low intensity fires, which are hard to detect by the thermal sensors of VIIRS or MODIS. And so we still look for better methods. Chris Weigel developed a so-called VIIRS I-band fire detection algorithm for high latitudes, which removes some false alarms and gives some ideas, distinguishes between different intensity fires. But we still depend on other observations to do a more accurate forecast. Of course, with modeling, we can do a lot. What we always look for, and that's one of my priorities here, to get evaluation data. We try to fly fires. We penetrate smoke plumes with our airborne optical particle counter. We have FLIR imaging, little aircraft, and fly through some plumes and test different model packages, aerosol packages, and see how it compares with the nature. And there again, we find that most of our challenges are not tuning. Of course, we always can do better with fuel load, and Randy will confirm this, I'm sure, and get better ground data before the fire starts. But the main challenge is to know how much is burning at what intensity. We are very excited to have a hyperspectral system now integrated in a low-cost aircraft, and we'll start flying this system this year. And so big push for getting evaluation data to improve the modeling capabilities and improve our initialization. And also we work on verifying GOES-R products. And so we are excited to further refine and get new data, especially for model verification. Thanks.
Okay, thanks, Martin. I waiting for Sarah to speak up, but didn't hear her, so I jumped in. Sarah, hopefully that's okay.
You're all speechless.
Yeah, that was a very nice presentation, and I think there's a lot of interesting stuff being done there. I guess I'll open it up for any questions from the group. Does anyone have questions for Martin?
Sure, this is Tom Hennessy. Can you hear me okay?
Sure, yeah, go ahead, Tom.
Sorry, my video isn't working, but Martin, thanks for a nice overview. While you were talking, I went to the UAF Smoke site, and I'm wondering, and I just clicked on the PM 2.5 page, and I'm wondering if you could do that also, just kind of walk us through what's on that site and how I, as a community member, might look at that information and use it.
So we run the let me go myself on the site first. If you go on smoke.alaska.edu, there is first at current fires. That's at the moment not actual. That's still from last year, but we will set in the latest next week we'll work in daily. Current fires are actually updated several times a day, every hour. And that gives another view of fire data from the Alaska Interagency Coordination Center. We have, they themselves have very nice GIS products on their webpage, but we choose to show that data again since we process the data and use to initialize our WRF-Chem models. And so you can find current fire activities once it's turned on. On top, you have a depth forecast tab. If you go there, so we have provide forecasts for fine particulate smaller than 2.5 micron, PM10, 10 micron, and for black carbon. If you click on PM 2.5, you will find an animation, and those are 72-hour forecasts, which will be initialized again, as I said, within the next days. And you have to let it run a little bit. It might flicker at the beginning, depending on your download speed. And you can follow the dispersion of PM 2.5 emissions from respective wildfires. And this is updated as a daily. Depending on the need, we might even go to 2 runs per day. Ravan has now, I think, every 6 hours a run, so her has the better update cycle. And I can say with good confidence, of course, the meteorology of her is high resolution rapid refresh is the best in West Alaska. We are working to initialize our WRF runs also with her. It's one of our big goals this year. At the moment, we initialize with a global forecast system model. But we verified those PM 2.5 version forecasts with ground-based and with some airborne measurements, and partly found good results. The simulating works, as I said, the main errors. Error is due to mostly wrong fire characteristics.
So could you explain these units of measure? This for PM 2.5, these are micrograms per meter cube. And at what elevation is that supposed to be projected?
That's at the 2 meter near the surface level. So those are concentrations in micrograms cubic meter of PM 2.5. Color coded, and you can see a color bar on the bottom. Everything which goes in the reddish, pink to reddish, is above 55 micrograms per cubic meter. Thanks for bringing it up.
And this is a loop that we're looking at. And thanks, Meredith, for putting that up. This is a loop from last year.
If you go further down, you can stop the loop, so you have some controls there. You can go to the end or toggle through it by hand. You also can upload higher up. There is an animated GIF of the same here for simple animation. If you have some speed problems, it was one request with some customers we had.
And from a health standpoint, at what level do those concentrations represent a health threat?
So those are color codes. I think they are in conform with the current EPA codes. Hazardous health situation starts at, is it 55? Unhealthy 35 micrograms. So everything which is orange and reddish is unhealthy to hazardous.
Mm-hmm.
And we get sometimes calls from people with respiratory problems, and it's pretty amazing how some people leave the state actually due to the smoke. Have to leave. They are very sensitive. Of course, Alaska has over 200 villages which are only accessible by airplane, and some villages don't have clean air rooms, so especially for the elders or sick people or people with a condition, the smoke can be a really severe issue, and they look at those forecasts very closely. Also, of course, smoke affects aviation. Like in 2004, we had in July, August, over 40 days hard instrument flight rule days. So there was almost no small aircraft traffic, only even Alaska Airlines had to cancel a few flights since they were below the minimums.
Okay, thanks, Martin. I think that was another question that I had, was to what extent this information was being picked up by different stakeholders and different groups, and it sounds like there are several entities that are using this actively. It would be great to find out more about how that information is being disseminated. And I think that, as you mentioned, once the HER and RAP models are set up to specifically do this over Alaska, I think there will probably be a lot more connection to these stakeholders just because of the popularity of those models.
Exactly, and it will be, ours is also experimental, near real-time forecasts, so the HER will run in, hopefully pretty soon in fully operational mode.
Good.
So this is Bill Schobert. Can you hear me?
Yes.
Yeah. So I'm with the JPSS program, and I just wanted to chime in here a little bit. The HER model is already running with VIIRS, and they're looking to bring MODIS in as well, fire radiated power. All it has to do is kind of open the Alaska window. So we close it during the winter to kind of save some run expensive, and then open it up again. The JPSS program has budgeted or provided money to Ravon and Ezreal to look at the RAP model to not only provide the fire radiated power into the RAP model for Canada, as some of the smoke obviously comes down from Canada into the U.S., but also as initial conditions for the HER. So the HER is already done. It's run for 2 seasons, 2 fire seasons already. And I guess the good news for Alaska has been relatively quiet fire seasons the last 2 years. So, but certainly it's there for use. As Sandy had said, we were up in Alaska. We were dealing with the meeting with the Alaska Fire Service, kind of showing the benefits of JPSS, but we also we are working with the geostationary. So we have an initiative called the Fire and Smoke Initiative. And Martin, I'm going to invite you to that. I don't know if Ravon told you about that.
Oh,
but
met Bill, remember? So,
what's that?
I'm part of it. Thank you.
Yeah, I just want to reinforce that. You're on our email list or not?
Yes, I'm on the email list.
You are. Okay, good. There's so many there, I can't remember exactly who's there and who isn't. So there's a forum to have these discussions. There's a forum. We're working on looking at a variety of different models, the Blue Sky, both Canada and the U.S., and other smoke models to bring in these fire radiated power and other things, and certainly looking at the impact of smoke on such things as temperatures, winds, clouds, and that's another powerful approach that the HER is kind of helping us with. So it isn't just the conditions on the smoke forecast, but it's smoke on the regular forecast. If you understand what I'm saying.
Yeah, thank you for that information. This is a really good discussion, and I don't mean to cut it short, but we do have our last speaker, Mike Brubaker, on as well. And so I'd like to make sure he has the opportunity to speak before we run out of meeting time here. So I guess in that sense, Mike, are you ready to present your presentation?
I am.
Okay, fantastic. I'll hand it over to you then.
He's in his car.
Thanks, everybody. Yeah, you know, I guess I'm still mastering Outlook, but I did accept the meeting, but I apparently forgot to check that that's Eastern Standard Time and not Alaska's time. So I had it on my calendar for 3 o'clock, not 11 o'clock. So I apologize to everybody for being out of sync. But I'm glad I caught at least part of the presentation. There is a really interesting conversation going on. You know, I work for the statewide arm of the tribal health system in Alaska. And part of what we do is to go out to clinics, mostly in South Central Alaska, but we also do extension services and technical assistance to communities all over the state. So we go to the water plants and the wastewater facilities and the clinics, and we do annual inspections, but we also build and design health infrastructure. And in recent years, we've begun to get more and more reports of the impacts of climate change and how, amazingly, communities, even sometimes in coastal Alaska, are experiencing not only higher temperatures, but of course increased wildfire and wildfires in places where they haven't really seen it before, and also just changes in extreme weather like more lightning events. And if you, I'm sure you're aware, but I'm sitting in a car. This is a car, it's typical for Alaska, that has no air conditioning. We travel in aircraft around Alaska, in small aircraft, which are not really set up to provide for any cooling. The infrastructure as far as homes and even clinics also are typically not constructed with any kind of a cooling system in them, although there is filtration. So if you want to cool down a structure or a vehicle in Alaska, you have to open up the windows. And so it's it's kind of the perfect storm when we're getting hotter, drier weather and combining that with increases in wildfire events, because you want to go inside and close up in order to get people away from the smoke. But if you go inside, you're going to get overheated. And that's the problem with our infrastructure. After big fire years in, I guess it was 2015 and 2016, we did a statewide survey of tribal environmental managers and communities all over Alaska and asked them if they had experienced periods of poor air quality related to wildfire smoke that exceeded 1 week. And 60% of the communities that we surveyed responded yes. And then when we asked them about whether there is any kind of shelter in their community where they can get out of the smoke, where they can have a cooling station, most of them did not have that. And so one of the approaches we've been applying over the past 2 years is to, as we go and we do our annual inspections of clinics, we're installing thermistors and beginning to record internal temperatures inside clinics. Because first of all, we want our patients to be comfortable and our staff to be comfortable, but also we want to have places where people can go and get out of dusty, smoky, hot conditions and get some relief from that. So we do have this data gathering effort going on, and we're also beginning to design in, under a project called Cool Clinics, the installation of air conditioning. And it's a very simple approach for most of the world, but not that common approach here. And the first place we saw that actually being applied was in Fort Yukon, which incidentally is a community that's been really heavily affected by high temperature and smoke over the past few years. In fact, I think the state record for highest temperature comes from Fort Yukon, of about 100 degrees. So the other thing I wanted to mention, kind of related to what we've been seeing as far as fire seasons, is just adaptation to extreme heat events. One of the first places we documented heat stroke or feveric seizures in children was not in the interior in Fort Yukon. It was actually in the lake areas of Lake Iliamna, where clinical staff were telling us that children were presenting in the clinic in seizure, and the reason being, based on the examination of the community health aide, was traditional practices of binding children in order to keep them warm and also to keep the insects off of them. So there's education needed in order for us to adapt to high temperature. And there's also education needed in order for us to have infrastructure that can accommodate people to live comfortably in their homes when these wildfire events are happening. So I guess taking out of a page out of the playbook of the medical community, we've been trying to do a better job of understanding the types of impacts that are being felt by communities. And, you know, this is standard practice for environmental health is, you know, if we're going to be able to understand and provide services to communities, we have to understand what they're concerned about. And that's how we engage, is we understand what they care about. So we have developed a platform where community members can go ahead and share with us what they're concerned about, specifically related to environmental change and environmental health impacts. And some of you probably are familiar with it. It's called the Local Environmental Observer Network. But this is our surveillance system, and this is how we stay in touch with communities around Alaska and increasingly other parts of the world too. But for us, it's how we understand how the environment is changing, what the impacts are, so that we can direct our services to these communities and to the residents there. So I thought what I would try to do is a screen share if I could, and just show you very briefly what the platform looks like and how to search it. And just for the sake of curiosity, take a look at what we have on there as far as wildfire and smoke events. Is that possible, Meredith? Can I go ahead and do a screen share?
Yep, you should be able to push the green share screen button at the bottom of the Zoom screen.
Got it. Okay. So this is our LEO network website. It has a basic search engine, and it has also a advanced search. So I'm going to go into the advanced search area. And when you go into this area, you can search by author, by topic, by community. So for example, if we went into and entered Fort Yukon, we're going to go ahead and get all of the observational content that they put in there. And what we found is this, for Fort Yukon, we have posts going back, well, it predates 2014, but on a wide range of topics. So there, most of the observations that have been posted are about the weather and water conditions and fish. But I think you get the idea that what we're trying to do is to provide a way, this is all of the communities that have representation in the system, is to provide a way for us to understand a profile and the timeline of events, significant events that are affecting communities around the state. So this is the actual community page for Fort Yukon. They have 5 different members who are posting observations. It's totally open to other people. It could be 100 in there if there was that many people that were interested. We can go ahead and view all of the observations in the system that are within a 50-kilometer radius. And we can take a look at timeline, kind of going back when these were posted. There's not that many observations actually for Fort Yukon. And we can also look at a map to see, based on GPS, where these observations have been made. And then each one of these has their own profile page with a lead author from a community member. So we got this one posted by Erica Mitchell with a consult from Richard Thoman with National Weather Service, talking about water levels in the Yukon River. But I'm going to go back and take a look here and see what we have in here for wildfire. So there's some really awesome systems that are available that are handheld apps for posting observations about smoke conditions. EPA has one, which is called can't remember. Smoke. Yeah, awesome app. When we see tools like that, we like to point people towards those. And quite often, if there's a larger event happening, you know, you're going to see a lot of people looking for tools like that to use. So it's sort of a teachable moment. But when people don't know about those kinds of tools, quite often they'll come to a site like ours, which is kind of a generalist site. So when people post observations about a wildfire happening in their community, we can go ahead and provide a consult and actually point them towards whether it's an academic institution or whether it's an agency or whoever it is that might have the resources to provide assistance. So you can see we have a few observations here. Let's see, here's from King Salmon. It's posted by Joni O'Diamond in 2015. She's talking about the lightning strikes. We can go ahead and post in related observations, and then we usually try to provide some kind of a consult and maybe point them towards some resources. So that's where calls like this and IARPIC are really super helpful, because we learn the community that are the technical experts and who have the more advanced monitoring systems or satellite surveillance systems, and we can help to point people towards that. So that's a lot of what we're trying to do with this system, is to point people towards the resources and introduce community members who have some knowledge about what's happening in their area to people that are interested and maybe can provide them with technical assistance. The other thing I wanted to point out is that this is a new feature on Leo. You can we mine news articles with similar kind of content. So if there's a news article about a wildfire happening up in the interior, we can go ahead and add that into the system as well. It's geocoded, it's topic coded, it's an event, and so it fits well in the system. And so when you now search, well, interestingly, you see the footprint of what was happening down in BC over the past summer. And all of these are articles in gray that were in different news media. And so I guess we've expanded the view by adding not only the local observers, but also the news media content as well. And let's see here. Anyways, that's what I've got. I'd be welcome any questions. Again, my apologies for the disorganization, and I really appreciate being included and having the opportunity to share some of this with you.
Thanks so much for that information, Mike. So we're running a little low on time. Just have a few minutes here, so maybe we won't have too much time for discussion. But I feel like this call has opened up a couple questions that maybe we all have encountered on this call. One is that there's a lot of tools at various levels of information. You know, you have the highly technical tools that UAF is developing. You've got all the observational tools and the community level tools. And I think it'd be great to, you know, decide, are we getting all the right information, all the right tools to the right people? You know, how are people finding all the information that's on all these different websites? I know some agencies are trying to post all the different links up, but just thinking about if we are getting the right information to the right people. Also, with all these tools, what do we still need? You know, what are gaps that we're still encountering, and what are the next steps to fill those gaps? So just a couple things that came up for me on this call. I don't know if anyone wants to take a minute or two for any questions. Respecting everyone's time, if you need to sign off, feel free.
Well, you know, one thing I'd like to mention is, you know, having made this connection and having this conversation at the, I guess is sort of the start of the fire season, you know, the opportunity to reconvene and maybe advise the state or regions or boroughs on how we might be able to coordinate our different tool sets to help respond more effectively to an event that's happening. And I guess I feel like maybe one thing's been checked off the list by just having this conversation, because we do have we do have this happening, and I guess we could reconvene it as needed.
Yeah, I agree. I think that's a good point. As we're encountering, you know, maybe some more questions as the fire season comes up, it may be an opportunity to talk again.
Yeah, and I'd be interested in knowing if there's a way to leverage Mike's LEO network for direct observations, either put tools in people's hands or just have observational information coming over the LEO network that could be of use to forecasters. I know that Martin talked about validation of the modeling, but I imagine more data are always useful, and so you set this large dispersed network that we might be able to harness in a way to provide real-time observations to help augment that modeling.
Yeah, I was actually thinking the same thing, that LEO could be potentially a very powerful validation source for some of the tools that are out there, if the right pieces are in place to ensure that we get, you know, consistent updates and things like that.
Well, I mean, I think the kind of the workflow for us is, I think with wildfire, we're very rarely the first ones to hear about it. Someone else knows about it way ahead of time. But you guys, you know, might be seeing, you know, forecasts or satellite imagery or other data sets, and you're wondering, you know, what the ground truthing is on that. And I think if you have a query, you know, and you're concerned about what might be happening in a certain region or in a community in particular, we do have the advantage of having pretty good connections, either through the tribal environmental staff, their administrator, the water plant operator, or community health aides. And all of them sometimes have their own valuable and unique perspective on how wildfire smoke is affecting that community. And so I would extend that invitation, is if we can be of help, and if together we might be able to provide some information back to the leadership in these communities that help them understand the risk, or to you know, respond to an event that we would be happy to use the tools that we have to reach out to the communities and act as a facilitator for that.
Yeah, and this is Bill Schoberg again, just to reinforce some of these models. So for example, the HER model does have, you know, smoke close to the ground. And so and that is very publicly accessible. So we're trying to work with the Alaska Fire Service. We're trying to work with particular IMETs, incident meteorologists, National Weather Service folks that are on the ground in particular fires. And, but it's something that even a mayor of a village or something could look at and see, oh gosh, you know, it looks like that fire, that smoke may be coming our way, and it may be low enough to impact us instead of elevated. So now that's a forecast, and you know, like any forecast, you run a risk of making huge decisions on something 24 or 36 hours in advance. But it certainly is something. And if we could get it out there for folks to look at and then get some feedback on Was it accurate? That would be a great start.
Well, you know, just from the aspect of mental health, you know, how stifling and how arduous it can be having an extended wildfire event. I think people want to know, are we going to get a break, or is the wind going to change? You know, is fire A under control and smoke should be reduced, and is there a fire B right behind it? You know, and I think providing best available information on what that forecast is would give people a little sense of control, because they might be making decisions over, you know, do our family come out and fish the camp, or should they wait? Do we get grandma out of the community and send her to Kotzebue instead? Are we going to be able to, you know, wait out this bad smoke event, or should we expect it to get worse? And then for us in the tribal health system, we might be making decisions like, do we ship out some air conditioning or some clean air shelters by barge? Do we fly them in? Do we need to purchase something to get them to, do we need to have a shelter set up, or by the time we get there, it's already going to be, the event's going to be over? So all those kinds of questions where people can improve their decision making, I think it's opportunity for us to work together.
And sometimes you're even not able to get to the villages, right? So you need it for planning, and since airplanes often cannot fly to the destinations when it's mostly needed. I was also wondering, is it possible to use Leon, your system, Leon, to not just to leverage data observations, but also to disseminate information? What Sarah mentioned before, to provide them tools, provide them updates.
Well, yeah, you know, and I would invite everyone on the call to sign in. It takes 2 minutes, set up a membership, because I think you'll kind of see how the system works. And if you have questions, you can kind of, you know, targeted questions, you can send them to me. But also, you might be able to provide us with suggestions on how we could, because we're actively developing. We have a software engineer working on the system every day. So we try to build a system that will work not only for the communities, but also for others that have the, you know, topic expertise on in these different areas. But you know, a lot of people want to follow a community, or they want to follow certain types of observations. So if you want to follow, I think one of the innovations we need to add is we need to add a topic area just for wildfire. And so then all of the wildfire community could check follow wildfire. It'll be tagged, and that'll give you an automatic email indication that there's a new observation that you might want to take a look at. As far as communication the other way, we do have ways for doing that. We have a wildfire project kind of in the wings that was set up with UAF so that you know, as any observations come in, we can at least put them onto one map. We do have a mapping capability too, so you can develop your own map, which means you can search the network for any existing observations, add them to your map. You can search the network for any news articles that you want to also map, put them on there, and then you can add your own data sets. You can add your own personal data and have it as a private map. So it does have kind of a Google Maps kind of feature where you can utilize the content that's already in the system. And then the other thing I want to point out is there is the directory part of it too. Everyone in the system has a profile, and you can contact people there. So if someone's posting an observation about they're obviously interested in wildfire and wildfire smoke, there's someone that hopefully would be interested in working with you.
Thanks. Great.
All right. Thank you, everyone, for the good discussion. And Sarah, I guess I don't know if you have other things to cover or not, but otherwise it may be about the time to end the meeting. So I'll leave that up to you. But I really appreciate all the discussion. I think it's been really good, and I've certainly it's been nice to put some pieces together here.
Thanks, Heis, and thanks for everyone for joining the call. I'm sure we could keep discussing for a half hour more, but in the interest of everyone's time, I think we'll end today and just be on the lookout for any updates from either the health and well-being team or the atmosphere team on maybe a continuation of this topic at a later date. Thanks, everyone.
Thanks. I just want to point out that the next health and well-being